Welcome everybody. So we now start talking about quadric surfaces. And before we talk about the quadric surfaces, we will be first looking at traces, and then we will look at the cylinders, and then we'll be looking at the quadric surfaces. So let's start with traces. Um, so first of all, um, if I look at the equation z is equal to k, where k is a fixed real number, then the graph of this equation is a plane that is parallel to the xy plane, and that passes through the point 0, 0, k on the z-axis. So this is a plane that is horizontal, that is parallel to the xy plane, and it passes through this point. And the reason is, when we write the equation z is equal to k, and we think of that as an equation in the 3 space, then we are looking for all points in the 3 space whose third coordinate is equal to k. So if k is 3, then the plane is going to go the plane is going to pass through the point 0, 0, 3. Similarly, if I have the equation x is equal to k, well, that's going to be a plane that is parallel to the yz plane, and it passes through the point k, 0, 0 on the x-axis. And also, when we look at the equation y is equal to k, the graph of that equation is a plane that is parallel to the xz plane, and it passes through the point 0, k, 0 on the y-axis. Okay, so these are planes that are parallel to the coordinate plane. So the xy plane, the yz plane, the xz plane, those are the 3 coordinate planes. And these 3 planes, they are parallel to the coordinate planes. Okay, so we are looking at equations in the 3 space. So we are looking at equations in 3 variables x, y, and z. Any equation in 3 variables x, y, z can be expressed as some expression of x, y, z equal to 0. That is, anytime I have an equation involving 3 variables, I can always put all the terms on the left hand side and make the right hand side 0. So for example, if I look at the equation of this sphere, this is a sphere of radius 2 centered at the origin. So, and its equation is this: x squared plus y squared plus z squared is equal to 4. So notice I can put the 4 on the left hand side and then make the right hand side 0, and then the left hand side would be an expression in x, y, and z. Okay, so now I'm ready to define what is a trace. So what's a trace? Well, simply put, it is just a 2-dimensional slice, or it is the let's say we are looking at the graph of an equation in the 3 space, and then the intersection of the graph with the plane is called a trace. So a trace is an intersection of a trace is the intersection of the graph of an equation with a plane. So it's a 2-dimensional slice of the 3-dimensional object, that three-dimensional graph that we are looking at. So as an example, let's say I have the sphere again here. That's a sphere of radius 2 centered at the origin. So if I look at if I ask, okay, what is the trace of this sphere, which is the graph of this equation? What is the trace of this sphere in the xy plane? Well, in the xy plane, notice that z would be 0. So I'm asking, what's the intersection of the sphere with the xy plane? Well, the intersection would be found by plugging in 0 for z, because in the xy plane z is 0. So then I get x squared plus y squared is equal to 4, which is a circle of radius 2. So what I see is that the intersection of the sphere with the xy plane is a circle of radius 2, and that's the trace. That's the trace of the sphere in the xy plane. Now, what is the trace of the sphere, let's say, in the plane z is equal to 3/2? So remember, z is equal to 3/2. This is a plane that is a horizontal plane. It is parallel to the xy plane, and it passes through the point 0, 0, 3/2. So what's the trace of the sphere on this plane? Well, how do I find the intersection of this plane with the sphere? Well, we just plug in 3/2 for z in the equation of the sphere. And if we do that, what we see is that we get x squared plus y squared plus 3/2 squared is equal to 4, which then we can simplify to x squared plus y squared is equal to 7/4. Now this is the equation of a circle of radius root of 7/4. So we see that the trace of the sphere, or the graph of this equation, in the plane z is equal to 3/2 is a circle of radius 7/4, centered at 0, 0 and comma 3/2, because z is 3/2, and then this is a circle of radius root of 7/4, centered at the point where x and y would be, where the center would be at 0, 0, and 0, 0 and 3/2. Of course, the graph of this equation in the xy plane is a circle, which would be here. Now let's look at the trace. Let's look at the trace in the plane y is equal to -1. Well, again, how do I find the trace in the plane y is equal to -1? Y is equal to -1 is a plane that's parallel to the xz plane, and in that plane, the intersection of the sphere with this plane would be found by plugging in -1 for y, and if we do that, we get x squared plus z squared is equal to 3. So again, that's a circle of radius root of 3, where the center would be at where the center would be at the point where x is 0, z is 0, and y is -1. So the center would be at the point where x is 0, y is -1, and z is 0. Okay, so then sometimes I'm just going to say the x. I'm going to loosely say the xy trace. So if I say the xy trace, what I mean is that it's the trace in the xy plane, and the equation for the xy plane is z is 0. And then the yz trace is the trace in the yz plane, for which the equation is x is equal to 0. The xz trace is the trace in the xz plane, and the equation for this xz plane is that y is 0. Okay, so I hope you are clear on what we mean by a trace of a three-dimensional graph, which is basically the intersection of the graph with the plane. So usually usually we look at the intersection with intersection. Usually we look at traces in the planes that are parallel to the coordinate planes. So let me just stop here, and I will see you in the next video where we talk about cylinders.